Have you ever wondered how an app like Spotify or Netflix can serve millions of people all at once without even skipping a beat? Well, it's not magic, it's an amazing technology called Kubernetes. And today, we're going to pull back the curtain on this invisible engine that keeps so much of the modern internet running.
Okay, I know, that sounds like the start of a really weird joke. But believe it or not, the answer to that question is the key to understanding one of the most powerful pieces of technology out there today. Just stick with me, and I promise it's all going to make perfect sense.
So, to really get why Kubernetes is such a big deal, we have to take a quick trip back in time. See, we started with these huge, expensive physical servers, one server for every single app. Then virtual machines came along, and they let us run a few apps on one machine, which was better. But the real game changer was containers, these tiny, lightweight, self-contained packages of code that are just incredibly efficient. And that changed everything. But, this awesome new way of doing things brought a whole new headache. I mean, when your app is made of hundreds or even thousands of these little containers, how on earth do you manage them all? How do you tell them when to start, when to stop, how to talk to each other? And what do you do when one of them just fails? Trying to do all that by hand? No way. It's just impossible.
And that's exactly where Kubernetes comes into the picture. You'll probably see it shortened to K8s a lot. That's just K, then 8 letters and an S. Think of Kubernetes as the conductor of a giant orchestra of containers. It's the one telling everyone what to do and making sure it all works together perfectly. You could even say it's like the operating system for the entire cloud.
To really wrap our heads around how Kubernetes works, we're going to use a really simple analogy. A box inside of a box, inside of another box. You get the idea. Just like a set of Russian dolls. We're going to start with the biggest, outermost box and work our way in piece by piece.
Okay, so our journey starts with the biggest box of them all, the cluster. Let's picture this as a giant green box. The cluster is the entire world where our application lives. It's like our very own self-contained digital data center. Everything that Kubernetes does happens inside one of these clusters.
And you can get these clusters in 2 main flavors. For real-world applications serving actual users, you'd use a cloud cluster, which is managed for you by someone like Google or Amazon. But for just learning and building things, you can run a local cluster right on your own laptop. It's a fantastic way to play around and experiment.
All right, let's zoom in one level. Inside that big green cluster, we find a smaller blue box. This is called a node. A node is simply a worker machine. It could be a computer in the cloud or even your own laptop. Its whole job is to provide the raw power, the CPU, the memory that our applications need to actually run.
Let's keep zooming. Inside that blue node, we find an even smaller box, this time a red one. This is the pod. And the pod is, without a doubt, one of the most important ideas in all of Kubernetes. You can think of a pod as a tiny, dedicated home for your app's containers.
Now here's something you really have to get. Kubernetes doesn't actually manage containers directly, it manages pods. The pod is the smallest thing you can create and control. It's basically a wrapper around your containers that gives them everything they need to live, like their own network address and a place to store things.
And you have to think of pods as totally temporary, completely disposable. They're like little interns. They get created, they do their job, and if something goes wrong or their job is just done, Kubernetes gets rid of them and just makes a new one. They are not meant to stick around forever.
And finally, we've reached the very center of our Russian doll. Inside that red pod, we find our last box, a yellow one. This is the container. This is where your actual application code, the stuff you wrote, finally gets to live and run.
So we have a green cluster with blue nodes inside, which run red pods that hold our yellow containers. It all fits together. But that brings up a pretty important question. Where do these containers even come from in the first place?
They're built from something called an image. An image is basically the blueprint or the recipe for your container. It's a neat little package that has all your code, all the other software it needs to run, and the instructions on how to start it up. When we ask Kubernetes to run our app, we're really just telling it, hey, go build me a new container using this specific blueprint.
Okay, now here is a really critical piece of advice. When you build an image, you give it a tag, usually a version number. It's so tempting to just use the tag latest, but you should absolutely never do that for a real application. Why? Because what latest points to can change without you knowing, and suddenly your app can break. You always want to use specific version numbers, like 1.2.1, so you know exactly what you're running.
So we've got all these pieces floating around. clusters, nodes, pods, images, but how do we actually control any of it? Well, we use a special tool called kubectl. Honestly, the best way to think about it is as the universal remote for your Kubernetes cluster. It's how you tell it what to do.
And the way it works is super straightforward. You, the user, type a command using kubectl. Kubectl then takes that command and sends it over to your cluster. And just like that, you can create a new pod, check on your nodes, or manage literally any other part of your entire system.
All right, that was a lot I know. So let's just boil it down to the 5 most important takeaways. First, remember Kubernetes is all about layers, like those Russian dolls. Cluster, then node, then pod, then container. Second, images are the blueprints for your containers. Third, pods are just disposable workers. Fourth, always tag your images with specific version numbers. And finally, kubectl is your universal remote to control the whole show.
So we've covered the basic building blocks of Kubernetes, the what. But the real magic, the part that's truly mind-blowing, is what happens next. How does this system automatically notice a broken pod and just heal itself? How does it go from handling 1 user to 10 million without even breaking a sweat? Well, that's where things get really interesting. Thanks for joining me.